We are continuing the multiple choice question related to the chapter force and motion. This is part 2. Or we can also say the same is related to gravity and gravitation chapter. Let's have the question. This is second part. Okay, what are the symbols for gravity, gravitation, acceleration due to gravity and gravitational constant respectively? And these are the options. And what are the units of gravity? Gravitation is the same thing, but these are the units given to you. Now next, name the term for the force exerted by a heavenly body to pull objects near its surface towards its center. Okay, these are the options. Now let's have number 1. We have to find the symbol for gravity. For gravity, gravity is force, it is denoted by F. Gravitation is also force, it is also denoted by F. That's why here we must have continuous 2F, F and F. Yes, it seems to be correct. This incorrect, and D. F and F seems to be correct. A and D. Next, acceleration due to gravity symbol is small g. Third should be small g. Here, small g is not present in third position. Here, it is small g. That's why A is not correct. D seems to be correct. And let's see the fourth one also. Acceleration due to gravity and gravitational constant. Gravitational constant is denoted by capital G. That's why option number D is the correct answer. Now the same physical quantities, but their unit is asked. Gravity, it is a force, it is measured in Newton. Gravitation, also force measured in Newton. Acceleration due to gravity, meter per second square. Now fourth one I'll see later, but Newton, meter per second square. Newton, yeah, not meter per second square. Newton, this is not Newton meter square by kg square. Newton meter per second square. Newton meter per second square. Option seems to be correct. The fourth physical quantity is gravitational constant and its unit is Newton meter square by kg square. Yes, the option number D is correct. Now name the term for the force exerted by a heavenly body to pull objects near its surface, maybe on the surface or near its surface, same thing, towards its center. What is it? It is gravity. That's why this is the correct option. Okay, now let's have another set. Which pairs of physical quantities have the same unit? These are the options. And number 5, if an object is taken deep inside the earth near its center, its weight, whether increase or decrease, remains same. The weight of an object. These are the options, and we have to find out the correct option. Okay, let's have question number 4. Which pairs of physical quantities have the same unit? Same unit. Now, why don't we see from D? Acceleration and gravitation. No. Acceleration meter per second square, gravitation Newton. That's why I don't want to go through this. Gravity and acceleration due to gravity. Gravity is measured in Newton. Acceleration due to gravity is measured in meter per second square. Gravitation and gravitational constant, they have two totally different unit. Gravitation and gravity, both of them are force. That's why they have same unit. Now let's see second part also. Acceleration due to gravity, meter per second square. Acceleration is also measured in meter per second square. That's why option number A is correct. If an object is taken deep inside the earth near its center, its weight certainly decreases, isn't it? On the surface, the weight will be maximum. If we go to the height from the surface, then weight decreases. If we go inside the earth, then also its weight decreases. Okay, the weight of an object decreases when taken far from Earth's surface. Yes, it seems to be correct option. Let's see another option also. Decreases when taken inside the Earth's surface. This is also correct. Both A and B are correct. Now it's confusing. Number C, decreases if the object's mass is reduced. Yes, this is also correct. A, B, C, all three are correct. All of the above statements are correct. Yes, this is the correct option. That's why we have to tick D. Now let's have another set. Which of the following statement is incorrect? We have to find out the incorrect statement. These are the options. And another question, where is the value of small g equal to 9.8 meter per second square? Actually, 9.8 meter per second square is an average value of g. But where is it exactly 9.8? This is the question. These are the options. Okay. 9. Which of the following statements is correct when a body is dropped from a height? These are the options. These are the equations and we have to select correct one. Okay. Let's have question number 7. Both the gravity and gravitation are forces. Yes, this is correct statement, but here we have to find out the incorrect statement. That's why A is not the correct option. The weight of an object depends on the earth's radius. Yes, this statement is also correct, not incorrect. G is relatively lower at sea level. No, G is relatively greater at sea level. This is the incorrect statement. That's why it seems to be correct. Let's see D also. Weight is a quantity expressed in terms of both magnitude and direction. Yes, weight is vector quantity and it is expressed in terms of magnitude and direction. This statement is also correct. That's why we have to select incorrect statement and it is number C. So we have to take C. Now, where is the value of G equal to 9.8 meter per second square? The average value is 9.8 meter per second square and actually it is at 45 degree latitude and it is taken as average value for the entire surface of the earth. Now next, which of the following statement is correct when a body is dropped from a height? Now I want to say that the correct option is B, S equal to half gt square. But how? You know that S equal to ut plus half at square. This is one of the equation of motion. If we are talking about a body, falling body, then it falls from certain height. That's why S, this is displacement can be taken as height. In place of S, I am writing H. And when a body is dropped, then initial velocity is 0 because when it is in your hand, then initially its velocity is 0 and when it starts to fall, then only its velocity goes on increasing. That's why U becomes 0 and acceleration produced on the body is acceleration due to gravity G. That's why I can write this equation this way also. H equal to U is 0, A is taken as small g. This is acceleration, this is also acceleration. Okay, now 0 multiplied by t becomes 0. That's why this part we don't have to write again. And h equal to what? Half gt square. In this way we can declare that second option is correct option. Okay, let's have another set also. If both the mass of two celestial bodies and the distance between them are doubled, what happens to the gravitational force between them? Okay, these are the options. Now next, in which of the following factors the gravitational force between two objects does not depend? We have to select the factor on which gravitational force does not depend. Where is the value of g equal to 0? These are the options. Okay, let's have question number 10. If both the mass of two celestial bodies and the distance between them are doubled, what happens to the gravitational force between them? The gravitational force between them remains same. But how? I want to tell you about this. This is the equation F equal to g m1 m2 by d square. If both the masses are doubled, it means m1 and m2 both are doubled and distance between them is also doubled. That's why I can write the same this way. m1 to 2m1, 2m2 and 2d. And 2 multiplied by 2 becomes 4 in numerator. 2 squared becomes 4 in denominator. Also I can write this way. Now 4 and 4 cancel each other. That's why new gravitational force will be equal to the same. I mean to say the old gravitational force and new gravitational force are equal. It means if both the masses are doubled and distance between them also doubled, the gravitational force between two heavenly bodies or celestial bodies remains same. Okay. Now let's have another. In which of the following factors the gravitational force between two objects does not depend? Distance. Gravitational force depends on distance. It depends on mass also. It doesn't depend on medium, whether the bodies are in air or they are in water, whatever it is, medium doesn't affect. Option D is none of the above. That's why option C is correct. Where is the value of G equal to 0? At the Earth's pole? No. At the equator? No. At Earth's magnetic pole? It is near to the Earth's pole. That's why this also incorrect. At the center? of the earth at the earth center. Yes, this is correct option. Okay, let's have another set. And this set is given in terms of statement, argument, etc. Look at this. Statement is given and two arguments are given, and you have to find out which option is correct among these four. In the same way, again statement is given and two arguments are given, and you have to find out which option is correct. Let's have the question. This an object at the center of the earth has zero weight. Yes, this is correct. Because of the resultant gravitational force exerted by the earth on the object is zero. Yes, this is also correct because at the center, the gravitational force of the earth mass from all the sides cancel each other. That's why resultant gravitational force of the earth will be zero and weight becomes zero. Argument 1 is also correct. Because the object is equidistant from the Earth's pole and the equator. No, this is incorrect because the center is not at the same distance from pole and equator. That's why statement and argument 1 are correct. Number A, statement and both argument are correct. No, the statement and argument 1 are correct. Yes, this is the correct option. Okay, let's have 14. Statement. G is a scalar quantity. No, this is incorrect because G is vector quantity. It has only magnitude but no direction. No, this is also incorrect because this is vector quantity. Its direction is towards the center of the earth. Its direction is towards the north pole of the earth. This is also incorrect. It means statement and both the arguments are incorrect. So we have to select the option. The statement and both the arguments are incorrect. Yes, this is the correct option. Okay, let's have another set. The weight of a body does not depend on, what are the options? These are the options. And again we have the statement and argument A and B. Looking at all these, we have to find the correct option. Okay, now let's have 15. The weight of a body does not depend on what? Volume of the body, mass of the body, small g, radius of the earth. It depends on radius of the earth. It depends on the small g. If g is more, then weight will be more. If less, less. Then mass of the body. If mass is more, weight will be more. Volume of the body. Yes, it doesn't depend on volume of the body. Now, number 16. The gravitational force between two unit masses separated by a unit distance is capital G. Yes. Its value is 6.67 into 10 power minus 18 Newton meter square by kg square. Looking at this, it seems to be correct, but look at the value. 10 to the power minus 18. This is incorrect. 10 to the power minus 11 is correct. That's why this argument A is incorrect. This value applies to all objects in the universe. Yes, this is correct. It means statement is correct, argument B is correct. Only the statement is correct? No. Statement and argument A are correct? No. Statement and argument B are correct? Yes, this is the correct option. Now I want to stop. I'll come with another part also because this chapter has a little more depth. That's why we'll meet in another class. I want to stop now. Thank you.